Howdy, bonjour, hi. In this particular video, we're going to be covering drawings. So what I've got open here is a previous assembly that I made in one of our previous modules, and it's a gear-mated assembly. So as you can see, it moves in tandem, and it's pretty nice. I do like this. But the one thing is we wouldn't necessarily, present this to, say, our project leads or to our professors. So what I'm going to do is I'm actually going to make a drawing. So you could either press make drawing from assembly, but I'm going to go the long way. And drawings are essentially, as this says, a 2D engineering sort of diagram of sorts. It's almost like a blueprint. And they're particularly useful for engineering projects because you can express dimensions on them, show multiple views, and it's not a very it doesn't require a lot of RAM to open up a drawing. It's a PDF usually. So automatically we can select a sheet size or set our own. I'm going to go with A3. I like its proportions the most, but we can change this at any time. And automatically we have an open document right here. So we can select a part or assembly, and there we go. And what I'm going to do is I am just going to plop this view down. And it's already put down a side view of our project, but I'm going to exit out. That was more or less so we could actually select our object. So I'm going to delete this guy as well and go over the basics. Now first off, one may ask, Nima, how do you change the size of your document? Well, that's a phenomenal question. What you can do is you can right click on any portion of the document, press this down arrow and click properties, and you'll notice you can change the name of your sheet. So you can also create a new sheet by pressing this tab button here. You could change the scale of your document, which I'm going to do. We have a pretty small part, so I'm going to make it a 1:1. And you could also change the size of your document here, as well as implement your custom sheet size. It is completely up to you. You've also got your zone parameters here. So setting margins and stuff like that, adding or removing portions of your table, it's really up to you. So I'm going to apply these changes. And yeah, also what we can change is this table right here. So this sheet format. What you can do is you could press edit sheet format with that selected and change up various things. For instance, we could change the drawing number. I'm going to say, for instance, I love CAD. Very nice. And press OK. And exit by clicking that little button that appears up there. Very nice. Now, the next logical step is adding model views or a standard 3 view. So a standard 3 view, if I click our open document, as you can see, it already implements 3 of the most basic views here. So no isometric views. You've got a front, back, top, any type of view that you would usually resort to. For some reason, the scale did not maintain. So what I'm going to do is I'm just going to use a custom scale right here and make it 1:1. You could also change the appearance of your particular drawings as well. Say you're not a big fan of the wireframe, what you could do is press shaded with edges and it will show up exactly as it would in your CAD. But usually I do like using the hidden lines visible tool. Hidden lines removed could be a bit tedious, especially if you have components that are within each other. So hidden lines visible. Okay, so we're going to press OK there. Augment the scale for this guy as well. So we go all the way down, use custom scale, 1:1. Beautiful. And you see that one followed suit as well. And we're going to change the type as well. Very nice. But, we're still sort of lacking. These views are nice, but they don't really describe a lot of what we want. So what I'm going to do is I'm going to press model view. And it'll give you different conformations. I'm going to choose isometric. It's definitely the most telling view in this particular case. So I'm just going to click up here and move this guy on over about here. Yeah, we'll reorganize it later. Okay. But there we go. That covers the basics of views. You could also do more by pressing on your assembly again, and it'll allow you to choose more views. So a trimetric view, dimetric view, or the current model view that you have open in your document. It is completely up to you. You could also mirror it as well, and yeah. Now, I've deleted a few of those LADs, and what I'm going to do is I'm going to implement more of our view tools, some of which may make this whole process a little more convenient. So if I click the projected view button and click a drawing, essentially if I move my mouse to the right, it'll create sort of another angle of our view. So this is, from what I could understand, it'd be like a front view of sorts. Furthermore, if I go to the diagonal, you'll notice it applies a corresponding almost isometric view as well. And this is repeated through any direction. So if I go downwards, you'll notice the view changes accordingly. So again, if you don't want to go through the process of clicking a new view every single time and you just want a reference object to create new views from, this is the tool to use. Furthermore, we also have the auxiliary view option. So if I click that, and it wants me to click a reference edge. So this is a linear piece of geometry, a 2D piece of geometry. I'm going to say this LAD here. Essentially what it does is it takes that edge and it spawns a new view from that edge. So that's pretty neat. It works for any type of edge too. Say I go back here and press that. Boom. Just like the projected view, just a little bit more restricted to one particular type of view per use of the tool. As well, this is something I use quite frequently. It's the section view. So you'll notice it'll give you multiple options for a cutting line, either a vertical cutting line. So if you can think of it, it's almost like what we're going to be doing is dissecting this model and taking one half of it and projecting it as a view. We could also go horizontally, so have a horizontal split section, and we could also do an auxiliary or an aligned. I'm going to stick with horizontal, and I'm going to go right through the middle of this LAD here. So if I zoom in, very nice, and click there, and press OK. And what you could do is you could flip the direction, but we'll do that after the actual model has been loaded in. So this is what is created as a result of our view. So I'm going to click down and I'm going to move this because I don't like this here. So, sorry, my bad. Okay, there we go. We'll get this previous guy out of the way. As you can see, what I've done is I've split this set of sprockets right down the middle, and it pretty much gives me an insight into how that looks. And this is particularly useful, say if you want to add different dimensions to different parts of your object, and it may be secluded by or covered by some other part of the model. So if I click my smart dimension here, what I could do is just apply a radial dimension to our hole. Again, this is very useful and used quite frequently in a lot of engineering projects. In addition, what we could use is the removed section view. So if I click on this LAD here, so it wants us to click two model edges of opposed or partially opposed geometry. So we'll click this edge here and we'll click this edge here. And essentially what you could do is you could put your line in between your two edges, and it'll pretty much do the exact same thing as your section view. So if I go right down the middle here again, click there and get rid of our previous section view. I'm sorry, it's a bit of an obstruction. Sorry, I can't speak. But this is what we get. So it's pretty much the exact same thing. It's just you'll notice since I hadn't selected the edges of these shafts, it doesn't actually show up. So what this is particularly useful for if you want like a portion of your geometry and a split section of that. Synonymous to that, what we could put in is a detail view. So if I take that guy out, take this guy out, and click detailed view, it wants us to sketch a circle. So this tool sort of acts like a magnifying glass of sorts. So if I go here, yeah, this looks nice. And sketch a circle there. This is what we're left with. So as you can see, it's pretty much zoomed in. It's scaled 2:1 to what it was originally. So again, this is particularly good if you have small sections of your objects that may be a little bit tough to see with a standard scale. If you want to magnify it a little more, Bob's your uncle. That's your tool. Now, say you're not really a fan of circles. You may have some sort of bias against them. That's fine. We could use different profiles. So what I've sketched up here is just this simple rectangle. We'll call it Bob V2. And what I'm going to do is I'm going to select this rectangle. So shift click, ka-chow, ka-chow, and press detail view. And once I do that, you'll notice that we've got the same sort of business going on here. It's just we're not dealing with a circular profile now. We have a rectangular profile. So again, you go into your sketch tools and let your imagination do the work for you. The next view modeling tool is a little bit more difficult to conceptualize, but it's very good for exposing the inner remnants of what you're working with. So if I click this broken out section tool, so first I'm going to select Bob V2 here and press OK. Essentially it'll ask you for a depth, and by asking for the depth, what it's saying is, okay, if you want to show the inner workings of your model, how far deep should we remove the top off of it? So this is what it's doing. It's breaking out a section. So if I press OK there, you'll notice this dashed bit is actually on the inside of what we're working with. So it's on the inside of this shaft. Again, it's a bit tough to visualize, especially with this model. I apologize for that, but that's one way of using this tool. Another way of seeing it, so I've made another version of Bob here, Bob V3, and I've implemented an isometric view. What I'm going to do is I'm going to click on these portions, and I'm going to press broken out section, and press OK, and preview. And it'll allow us to choose a depth. Perhaps this will be a little bit easier to visualize, but I'm going to click, say, this edge here. And if I press OK, you'll notice what it's done is it's taken that rectangular portion, so you can see where it's cut, and it's implemented the cut as far as the depth that we selected. Again, it's a little bit tricky to visualize. I would most likely use the section view tool for purposes like this, but again, it's nice to experiment with new tools. Referring back to our original model here, so what I'm going to do is I'm going to remove this previous view, so take out this broken out section, and we have the break view tool. So the break view tool is particularly useful. First, I'm going to change this to a horizontal break line. It's very good if you have, say, a portion of the particular model that you want to exclude, or maybe you don't have enough space. The break view is particularly good for that, and you could change the size of your gap. You could also change the style of your break line. So I'm going to make this a straight line, and I'm going to click once there, and I'm going to click once there. And what you'll notice is these two are split apart. So again, another fairly useful tool to use. As well, we have the crop view option. So this is very similar to, if you remember, detail view. So if I put this rectangle out here again and go to view layout and press crop view, you'll see with the crop view it does pretty much the exact same thing, except for the fact that it doesn't apply sort of a magnification scale factor. It just sort of removes any redundant pieces of your particular model that you don't want. Okay, and we're back. So as you can see, I have removed our previous views and I've implemented these views as well. Furthermore, you'll also notice this sort of pink funnel filter looking icon right by my mouse, and this is a very pesky thing to work with. It's essentially a selection filter that only allows you to select, in this case, vertices or faces even. So to get rid of that, you just press F6. So Fn, F6, F6. There we go. And it's gone. My apologies for that. It wasn't working for a moment there. So I'm going to press Smart Dimension here, and I'm going to demonstrate how to dimension, an essential part of making drawings. This is how you demonstrate how large your models are to your employer, client, etc. So by clicking the Dimension tool and clicking on, say, this vertex, this vertex, and this vertex as well, and click there and press OK. We've implemented this sort of width dimension here, which is very nice, very standard. Furthermore, if you move your mouse here, you could add top text. So say we'll add width. We'll say this is support width. You can also add text to the left, text to the right, and text on the bottom. Again, it really comes down to how you want to format your file. Furthermore, you could also indicate 2 times something. Oh, my bad. There's also different ways of doing that as well. Furthermore, this isn't restricted to simply just linear dimensions. We have radial dimensions we could implement too, which is the beauty of this model in particular. If we press that, we'll get the diameter of this lad here. We could also go from our vertex to our height here. You could also change the type of dimension too. So this is the minimum length. Meanwhile, this is going to be our vertical length if we had a right triangle. Again, it really comes down to where you want to put your dimension. You could also drag them around. So say you're not happy with the position, you could just move this lad around wherever you want and declutter your drawing to some degree. There's also different types of dimensions as well. So I've already gone ahead and tested a few of these, but we were using the Smart Dimension tool this whole time, which is comprised of all of these different types of dimensions as well. But we'll look at them one by one. Horizontal dimension and vertical dimension are quite linear. Essentially what you do is you take any horizontal length. I've already done this, so this is a bit redundant, but you take any horizontal length and you put a dimension in there. Same thing for the vertical dimension. It's just we're dealing with vertical lengths as well. I'm going to get rid of both of these because we've already got these 2 dimensions located. As well, we have the baseline dimension tool. So essentially what you can do, this is particularly good if you have a model that doesn't have clear edges and you still need to find a reference distance between 2 different points. So say we want to click this line here and this line here. What happens is we set our baseline with the first click and we set a target of some sort with our second click, and it'll give us the most logical distance between the 2. This also works with vertices as well. So if I go here and click on this guy here, oh, my apologies, misclicked. But if I go here and click on this lad here, as you can see, it gives us a minimum length. And that's mostly because we haven't really given it any 2-dimensional length for it to, insinuate a vertical distance that it usually would. As well, we have the ordinate dimension tool. Now, the difference with this is it isn't necessarily implemented in your Smart Dimension tool. This is something you have to select on your own, but these 4 definitely are, or these 3, my apologies. But essentially with the ordinate dimension, what you do is you click an edge and click again. You've set your 0, as you can see. And then what you could do is you could click once on one part, it'll give you your dimension there. You could click on another portion, another dimension, and you can click on another portion, another one, as DJ Khaled would say. And what you've got here is multiple dimensions based in one dimension. How convenient. As well, we have the chamfer dimension tool. Essentially what you can do, so what I'm going to do is I am going to open up our model. So open recent SEM5. Let SolidWorks work its magic right now in opening it up. There we go. It's already open. My apologies. And I'm going to apply chamfers. So if I go into assembly here and click on chamfer, so this is different from our featuring chamfer, and click on this lat here, give it a less drastic chamfer, 0.1. That should be adequate. Now if I go back into our drawing, this should update. There we go. And with the chamfer dimension, what you can do is you can click on that, click on your chamfer, and it'll give you all the specifications of your chamfer. So the top line is sort of your reference, and when I click this diagonal line here, it knows that we applied a 0.1 inch chamfer at an angle of 45 degrees. Very nice, and it's very clear to see what you've done here. The same thing applies with fillets, it's just, or fillets, my apologies. It's just you'd use radii instead. So you'd indicate your fillet's radius. Now, I intentionally skipped the angular running dimension tool. And that's mostly because of the fact that I don't necessarily have a model on hand right now that this would work well for. But think of it like so. Say we have this dimension here, so this was from before. I'm going to delete this guy and apply a new angular running dimension. And click on this circle and apply a reference. Think of a cylinder almost, or a circle with little hitches with different thicknesses on top at different angular coordinates. This tool is particularly good at finding the radii between the start and end of each of those different thicknesses. So a nice little surrogate may be our sprocket teeth here. As you can see, it doesn't work quite well though. Again, this is something that comes up frequently if you're in shaft design, but other than that, I wouldn't necessarily be too concerned about it. Just know that you can click vertical edges with it, and it'll tell you the radii, or the amount of the angular distance that particular feature spans. It's almost like the ordinate system, but in its angular counterpart. In addition, what we can apply is nodes. So if I go here and click somewhere, you can type down anything you want and apply different fonts and so on and so forth. That's quite linear. You can also apply linear note patterns. So if I get our note in here again, and, oh, my apologies. Get our note in here again, so I'll say hi, very nice, press OK, and press our linear note pattern. You could click on your note, and just like our featured patterning tools, you can add multiple instances. So we have multiple highs. How friendly. As well, we have the circular note pattern. It's the same sort of thing, it's just you choose an axis of rotation and go from there. As well, we have these three symbols here. For instance, you have a surface finish symbol, and you can apply that to any surface here, and say whatever you want with it. So, say I want this to be matte, or anything like that. It really comes down to your project. I haven't used it too often. Furthermore, you have your weld symbol. So this indicates any portion where the machinist needs to be cognizant of your weld. More importantly though, is the hole callout. So if you click here, it'll automatically give you dimensions of your hole. So in this case, we have a hole that is 0.31 inches, that's its diameter, and then we also have its hole depth. Again, quite nice. It's a very convenient tool to use, and you could apply the same text settings that we had from before. However, more importantly is your bill of materials. So what I'm going to do is I'm going to click on a particular drawing view. We're going to click here and attach a standard type of bill of materials. So, and we'll remove this guy here. This is a balloon that I was experimenting with before. As you can see, if you click a particular drawing view, it'll give you a sequential list of what you used in that particular drawing view. So in this case, we have 2 shafts, we have 2 support beams, and then we have 2 sprockets. Very nice. And the useful thing about this is, with this bill of materials, you could implement balloons. So you could press balloon here and click on this, for instance. This is our shaft, and you'll notice it applies a 1 automatically, part number 1. If you want to indicate that this is your support beam, you click there. 2, my apologies. And same thing for our sprocket, 3. Again, this is very nice if you have multiple parts and you need to distinguish what is what. You can also apply a description to this. So if you fill out this cell, you could say this length has a minimal tolerance, so on and so forth. Again, it's really up to you. But you have your same speech tools that you had from before as well. So I'm going to remove these. You can apply an auto balloon. So if you click here and click a drawing view, it'll automatically assign balloons to different parts of your model. Sometimes it may not be to your preference. Sometimes it may work perfectly. Again, test it out, see what works best for you. In addition, we have our center mark tool. So if I click here and here, it will apply sort of a cross to designate where the center of our circles are. So this is nice for machinists who have to discern where, the center of your hole is, for instance. That is completely up to you. You could also change the angle, so offset it a little bit. As well, you could also auto insert it for all holes, all fillets, and all slots in your drawing. But I've already done this manually, so no need to worry about that. In addition, or finally, so to say, we can have our center line tool. And this is very easy to use. You select a cylindrical surface, or as this indicates, 2 edges or sketch segments, and it'll automatically apply a center line for you. So that's very nice. Again, it's another piece of reference geometry that'll make the lives of your machinists a little bit easier. You could also auto-insert these particular center lines. So I'm going to get rid of our last 2 and go on center line again. And by pressing auto-insert, it'll essentially allow you to click on a view. So I'm going to click on that particular one right there. And as you can see, it's already gone haywire and implemented a ton of its own views, or center lines, my apologies. Again, these may not be ideal. It makes it a little more confusing, so use this tool at your own discretion. And last, but certainly not least, we have our area hatch/fill tool. So, as the name insinuates, you select an area, and you can apply a hatch or a solid particular color to it. It's more of, again, a way to discern what is what. Say you have two different types of materials, like an abrasive side and a smooth side. This is how you indicate that. And then you put a legend somewhere if you'd like. Yeah. That was one of the finaling portions of modeling. Or I'd say it is the final portion of modeling by McGill Academy. We may be putting out more videos, in particular when it comes to file formatting, so stay tuned for those. Or if you're looking at this in the future and have already seen those videos, I'm glad. This has been Nima from McGill Academy, and I'm glad you've joined us for this journey. Best of luck with your studies.